Hello friends, welcome to Quick Learn website, and I am very excited to inform you that in Quick Learn I have recently launched my website, that is www.quick-learn.in. This website is especially for all the engineering and diploma students and those students who will preparing for competitive exams. So in the blog section of the website, you can find the notes of all the electrical and electronic subjects, just like basic electronics, microcontroller, microprocessor, power electronics, and slowly I will add more notes in the website. And if you are preparing for any government competitive exams, then check also my MCQ series, that is multiple choice question series, and previous year question papers. That will help you in your competitive exams. Here I also upload the quiz test or mock test for ONGC, UPPCL, or for different type of competitive exam previous year question papers. Or for latest update, please join my Telegram channel. The link of my Telegram channel I will give in my description box. So stay continue and keep watching and keep visiting my website. Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you single phase half bridge inverter with resistive load. This is lecture number 34 of Power Electronics series. So let's start with the topic. Before I discuss the single phase half bridge inverter, first we know about what do you mean by inverter or what is the basic function of inverter. So inverter is an electrical device which is used to convert fixed DC power into variable AC power, or we can say that it is basically a converter that converts DC power into AC power. So here we see in the diagram, this is the inverter. The input of the inverter is DC power, and at the output side, inverter convert that DC power into the AC power. This AC power is variable AC power. Why it is called variable AC power? Because in AC signal, here we vary two parameters. First is the frequency of the AC signal and second is the magnitude of the AC signal. That is why it is called variable AC power. Now there are number of application of inverter. These are, first is inverter are basically used in UPS system. It means it is used for uninterruptible power supply system. Second is inverter are basically used in speed control of AC motor, and third is inverter is also used in reactive power compensator. These are the commercial application of inverter. But we know that there are some other application of inverter. Inverter are basically used in domestic applications, such as if the power cut off in our home or power failure will be occur. To operate all the AC operated equipment, we use inverters. So these are the basic applications of inverter. Now the classification of inverter. Inverter can be broadly classified into two types. First is voltage source inverter, that is VSI, and second is current source inverter, that is CSI. VSI and CSI I have already explained in my previous video. So if you want to learn about the VSI and CSI and the difference between both of them, please refer that video. The link of that video is given in my description box. So there are basically two major classification of inverter. First is voltage source inverter. Voltage source inverter is further divided into two parts: single phase voltage source inverter or three phase voltage source inverter. Single phase voltage source inverter is further classified into two types: single phase half bridge inverter and single phase full bridge inverter. Now the second classification of VSI is three phase inverter. Three phase inverter is further classified into two types: 120 degree mode inverter or 180 degree mode inverter. Next classification is current source inverter. Current source inverter is classified into two types: single phase current source inverter or single phase ACSI. So these are the major classification of inverter. So in this video I will explain you the working of single phase half bridge inverter with resistive load. So this is the circuit diagram of single phase half bridge inverter circuit. In single phase half bridge inverter circuit, here we use two thyristor T1 or T2. Or in place of thyristor, here we use any power semiconductor switches just like MOSFET, IGBT, because these type of switches having self-commutation property. So T1 and T2 are work like a power switches. And in single phase half bridge inverter, here we use only two switches T1 and T2. But in case of full wave bridge inverter, here we use four switches T1, T2, T3, T4. Now across each thyristor, here we connect a diode in anti-parallel. So D1 diode is connected in anti-parallel with respect to T1 thyristor, and D2 diode is connected in anti-parallel with respect to T2 thyristor. Now here we see at the source side, here we use in case of inverter the DC voltage or DC power supply. So here we use a balanced DC power supply Vs by 2 or Vs by 2. How we generate this kind of DC power supply? So to generate this kind of balanced DC power supply with the help of 3-wire DC system. What is 3-wire DC system? So this is the 3-wire DC system. At the input side, here we use a DC generator that generate a DC voltage Vs. And at the output side, here we generate a balanced DC output voltage, that is Vs by 2 at the first half and Vs by 2 at the second half with the help of this neutral wire. So here we connect from the center of the wire, here we connect a neutral wire that will create a balanced output at, that is Vs by 2 and Vs by 2. And why this is called 3-wire DC system? Because this is the first wire of the system, this is second wire, and this is third wire. And these 3 wire create a balanced DC output voltage. And we know that this is a single phase half bridge inverter with resistive load. So here the load is resistive type. And the response of the circuit is totally depend on the type of load we use here. If we use resistive load, the behavior of the circuit is different. If we use RL load in place of R load, the response of the circuit is also different. So how circuit will be respond is totally depend upon the type of load we use in the circuit. So this is the single phase half bridge inverter with resistive load. So here we use resistive load. Now here I will explain you how single phase half bridge inverter will respond if we use resistive load. So here load is resistive type. Now during the first half cycle, we triggered T1 thyristor with the help of gate current Ig1. If we apply gate current to the thyristor 1 will be start conducting. It means it is behave like a closed switch and current flow in this direction. Because we know that this terminal is positive this time and this is negative. So current always flow from positive toward negative. That is why the direction of current is this. If current flow in this direction, the output voltage across load is just equal to the input supply voltage, that is Vs by 2. And the polarity across the load is this terminal is positive and this terminal is negative. Because current flow in this direction, current always flow from positive toward negative. So this terminal is positive and this is negative. And the output voltage is equals to Vs by 2. The full output voltage will appear across the load. So here we draw the waveform from instant 0 to pi by 2. If this is pi by 2 and this is 90 degree. So from 0 to pi by 2, T1 thyristor will be turned on. T1 thyristor will be turned on and the output voltage across load is equals to Vs by 2. So the magnitude of output voltage is Vs by 2 from 0 to pi by 2. Okay. After pi by 2, what will happen? after pi by 2, here we see we not provide any triggering pulse to T1 thyristor. So T1 thyristor will be turned off and we provide a triggering gate pulse to the T2 thyristor, that is IG2. So T2 thyristor will be turned on during pi by 2 to pi. Okay, if this instant is pi, so from pi by 2 instant to pi, T2 thyristor will be turned on and T1 thyristor will be turned off. In this duration, when T2 will be turned on, it behave like a closed switch. The current flow in this direction, because we know that this terminal is positive and this terminal is negative, and current always flow from positive toward negative. So the direction of current is this. If current flow in this direction, the polarity across load is this terminal is positive this time and this terminal is negative. But we have assumed that previously this is the reference direction of current flow. We assume this is the reference direction. This is positive and this is negative. So this is the reverse direction of the current flow. So in this case, the output voltage across load is minus Vs by 2 because the polarity is reversed this time. So from pi by 2 to pi, output voltage is minus Vs by 2 and T2 thyristor will be turned on this time. Now what happened after pi? So after pi, again we will give triggering pulse to thyristor T1. So T1 will be turned on and we remove the triggering pulse from T2 thyristor. So T2 thyristor will be turned off this time. Again current flow in this direction, the reference direction. So the output voltage across load is again Vs by 2. So here we see the output voltage is again Vs by 2 from pi to this point, 3 pi by 2. Okay. What happened again? Again we remove the triggering pulse from T1 thyristor. So T1 thyristor is off this time and we provide triggering pulse to T2 thyristor. So this time T2 thyristor will turn on. When T2 will turn on, current flow in this direction. This is the reverse direction of the current. If this is the reference direction, previous direction is reference direction. So this is the reverse direction. This terminal is positive and this is negative. So the output voltage across load is minus Vs by 2. So this is minus Vs by 2. So this is the waveform of output voltage across load in single phase half bridge rectifier when we use a resistive load. Now what about the output current waveform? We know that if we use resistive load in the circuit, we know that in case of resistive load, the current and voltage lie in the same phase. V and I is lie in the same phase. There is no change in the voltage or current wave. And logically here we see during the 0 to pi by 2 time instant, current flow in this direction. This is the reference direction. So this time the output current is also positive. But the magnitude of output current is, we know that from Ohm's law, I equal to V upon R. So here V, it means the supply voltage. So supply voltage is Vs by 2. So the output current is Vs by 2R. So the magnitude of output current 0 to pi by 2 to Vs by 2R. Okay. After pi by 2, what will happen? T1 thyristor will be turned off and T2 will be turned on. When T2 will be turned on, current flow in this direction. Because this terminal is positive and this is negative. If current flow in this direction and previous direction is the reference direction, we have to assume that previous direction is the reference direction. So this direction is reverse direction of current flow. In this case, this terminal is positive and this is negative. So current flow in reverse direction, the minus I naught current will flow across the load. So here we see in this case from pi by 2 to pi, from this point the reverse current flow across the load and the magnitude of reverse current is minus Vs by 2R. Next, again T1 thyristor will turn on. So here we see the waveform of output voltage and output current will be same, because in case of resistive load, the magnitude of voltage and current is always equal. There is no phase difference between voltage and the current. That is why in case of resistive load, the voltage waveform and the current output waveform is always same. Now the analysis of half bridge inverter with resistive load. To analyze any circuit, there is two questions arise. Why we do analysis of any circuit and how we do analysis of any circuit. Why and how? These are the two questions that will arise in our mind. So the analysis of half bridge inverter is done with the help of Fourier expansion. And why we do analysis? Because we know that our half bridge inverter circuit produce square wave output. If we want to split or break this output voltage into several elements or several components, just like first component is fundamental component, second component is the second harmonic or third harmonic of the component. So to separate all the components from the main output voltage waveform, we done the analysis. So if we want to break this output voltage into the first fundamental component, so this is the first fundamental component of the output voltage. Now if the frequency of this output voltage is F, again if we want to split this fundamental component into several other components, what we do? If we get the 3 frequency, 1, 2 and 3 frequency, this is called the third harmonic of the output voltage waveform. If we get 5 frequency at the same time period, 1, 2, 3, 4 and 5, this is called the fifth harmonic component. So to separate all the components from the main waveform, we get analysis of the half bridge inverter, and this analysis we will do with the help of Fourier expansion. And I will assume that you all know about the Fourier expansion and Fourier series. So this is the Fourier expansion of output voltage waveform, where we have 3 components. First is A naught. A naught is the DC component present in the output, and we know that inverter is a circuit that converts DC into AC. So we not required any DC component at the output side. So we not required the A naught component. Next component is cause wave. We also not required the cause wave at the output side. We only required the sine component of the output. So here we analyze only this component, Bn sine n omega t. So here we start the analysis of this component only, Bn sine omega t. So to find different component of Bn, we know the formula. So we know that the Bn equal to 2 pi integration Vs by 2 sine n omega t d omega t. If we want to calculate first fundamental component, then here we put the value of n equals to 1 to get first fundamental component. So in place of n, here we put 1. After putting 1, we get B1 equal to 2 Vs by pi. This is the value of first fundamental component of the output waveform. So in this way we calculate the first fundamental component. Now if we want to calculate the RMS value of fundamental component, the root mean square value of fundamental component, so output voltage V01. So V01 RMS equals to V01 divided by root 2. So the value is root 2 Vs by pi. This is the RMS value of first fundamental component. Now analysis on AC side. Why we do analysis on AC side? Because if this is the first fundamental component of the output voltage, so AC analysis we do to find out the total harmonic distortion THD or of the output voltage. So to calculate total harmonic distortion, the formula is root 1 by G square minus 1, where G is the distortion factor. How to calculate this distortion factor? This distortion factor tell us how much distortion present in the output voltage waveform. And this will calculate with the help of this formula. The RMS value of first fundamental component of output voltage and the RMS value of the output voltage. So by putting these two values, we get the distortion factor. So the RMS value of first fundamental component we have already calculated. Now the same procedure we have to apply to calculate the output voltage RMS value. By putting these two values, we get the distortion factor, and this value we will put here. So after calculating this, we get the total harmonic distortion present at the output side. So we can say that the total harmonic distortion present at the output voltage is 48.43%. But as per IEEE, the total harmonic distortion should be 5%. So these three formulas, the distortion factor, the total harmonic distortion and the value of total harmonic distortion will be very frequently asked in our competitive exams. So this is the complete analysis of single phase half bridge inverter with resistive load. So hope you like the video. For more interesting video, please like, subscribe and share my channel. For notes, please visit my website, that is www.quick-learn.in. And if you are doing preparation for any government competitive exam, then check out my MCQ series in my website. Previous year question paper I also upload there, and also give mock test which will help you in your competitive exams. So stay continue, keep watching and keep sharing my videos. Bye bye.